Oh, man. All right, Salman, where are you traveling to?
I'm gonna travel to the past, get a dinosaur egg, come back to the present, and then hatch it.
You're going to travel to the past, bring a dinosaur egg back, and hatch it.
Yo,
Why?
I like dinosaurs.
Okay.
It will probably give me a lot of money if I sell it. Like a lot of money. It's pretty rare. It's one of a kind.
Yeah, and it's going to be a limited time, too. Why?
Because he can only live for so long.
Correct, and there's no way to keep the species alive if there's only one of them.
I mean, you use the DNA. I don't know. You use the DNA, and then put it in the eggs, whatever.
No, you're talking movies now.
Yeah, whatever. I mean, they can do it somehow. But
No, they can't.
The only thing I'm looking at is the money.
The only thing you're looking at is the money.
Yeah.
Okay.
I'll probably make millions.
Then why wouldn't you just go back into the past and bet on somebody to win the Super Bowl, the soccer championship, because you would have already known who had won.
Yeah, but I wouldn't have enough money to bet that much on it.
Okay. So you want to time travel for pure profit reasons.
Yeah.
Okay, fair enough. Who else? If you could time travel, would you rather go into the future or into the past? Surely Salman's not the only one who wants to profit from this. Come on.
You get billions of dollars.
I don't know you're going to get billions of dollars.
Who's not going to spend billions of dollars for a dinosaur egg?
Me.
Not you, but for somebody that has billions of dollars, that wouldn't be that hard.
So you think these billionaires who have billions of dollars would want an old dinosaur egg?
Of course. And it's still alive. It's not alive.
Well, no, you just brought an egg. There's no guarantee the egg will hatch.
Yup.
So they're paying billions of dollars for something that could just never come to fruition.
Yeah, I guess so.
Okay.
I mean, there were dumber stuff that billionaires spent money on.
Oh, there's no doubt there. No doubt there. All right, guys, share your ideas. Future? Why? Wait. Huh? So you want to go to the future so that if someone trips, you could come back into the past and be like, this person's going to trip, let's watch. Okay. I can't argue with logic like that. Jose?
I think the past.
Okay.
I like era.
The what?
Era.
What era?
I mean, not just that.
Because how far back into the past would you travel?
Could you do only one time?
Well, yeah, one time. You could travel one time into the future, one time into the past, wherever you want. And then you can obviously come back.
2015, it was like more fun. I mean, personally.
Wow, you're going way into the back. You're going 10 years. Okay. So we'll go 10 years into the back. All right. Who else? Future or the past? Natalia, would you go into the future or the past? About how far? Are we talking like 40 years from now when you'd be 50 some years old? Are we talking 100 years from now so that you could see what it would be like for Like if you ever had children, their children, or something like that, or just somewhere in the future. Like 100 years, just see what it's like. Okay. All right. Heavenly, which way would you go? Past or future? The past. Is there something you want to go back and see? Or is there a certain time period that you would like to go to? What's that? 2016? Is there something that happened there that you want to go see again? What was that? Just a cool year. You want to go back to a time that you lived that you had fun at. Okay, that's fair enough. That's fair enough. Allison, what about you? If you could travel into the past or into the future, which one would you rather travel into? Future? See what things are going to be like? Okay. All right. Damien? Would you rather travel into the past or into the future? If you could time travel. Okay, how far back do you want to go? What do you want to go see? You want to go see the what? Okay. So when the pirates sailed the seas and things like that? Okay. Very cool. Very cool. Jesus? Future? What do you want to go see? How far in, let me rephrase that. About how far into the future? Short time, long time? So where you wouldn't be around to see. Okay. Right. Fantasia?
I was supposed to go to my cousin with my favorite clients.
If they were supposed to call you down, yeah, go ahead, hurry up. All right. Evelyn, would you rather go into the past or the future? The past? How far back do you want to go?
Maybe like the 80s.
Okay. To the 80s? Those were not bad years. All right. Past or future? Is there something specific you want to go see or just a year or a time in mind? All right. Karina, what do you think? Would you even want to try time travel? No, you're happy just where you are? Okay. Fair enough. Fair enough. Alexander, you want to go in the past or you want to go in the future? Past? What do you want to go see? Oh, you want to go all that way back. Okay, that's interesting. Be the first person around. Okay, okay, okay. I think if I had the choice, ladies and gentlemen, I would go back into the past. And I would go back into probably around the time of like the Old West when things were being settled and that was first starting to happen, just to see what it was kind of like. I don't know. I think that would be kind of cool. So, all right. Today we got to get that quiz taken that we didn't do yesterday. I will give you the choice. Would you rather do that at the beginning of the hour, where we will do things afterwards, or would you rather do it at the end of the hour, where it is the last thing you do? So we're going to take the quiz. Would you rather take the quiz first, get it out of the way, then work on things, or would you rather do it at the end of the hour where when you're done you have nothing else to do? Let's do it now. All right. Take out your computers, ladies and gentlemen. Okay? Take out your computers. Yes, sir. I will go see if there's one in the back. There you go. All right. Give me just a minute here, ladies and gentlemen. While I am getting this set up, take out your periodic tables. Put them on your desk. Your yellow periodic tables with any notes that you wanted written on them, ladies and gentlemen. All right. Since we got the room spread out, if there are two of you in desks next to each other, one person go to a spot where there is two open desks. Spread out, please. All right. Give me just a second, ladies and gentlemen. I have to put in the people who aren't here.
Is it called Unit 1 Quiz 2?
Yes, but it's not open yet. Hang on. It's going to tell you it's not open yet, so hold on.
For me, this is I already did it.
What did you ask? Does it say Unit what?
It's a Unit 1 Quiz 2.
No, this one is Unit 2, Quiz 1. Unit 2, Quiz 1. That's why it'll say you already did it, because you did already do that one. All right. It is the Unit 2 Quiz 1. I just published it, ladies and gentlemen, and put it out there, and now you should be able to get to it. So we'll find it in the modules. Again, when you go to it, you are going to have to close down all of your other screens. And it is right here, Unit 2 Quiz 1. Again, the first couple of questions, ladies and gentlemen, are for you to describe a solid, a liquid, or a gas. For you to describe it, you need to tell me, does it have a definite shape or no definite shape? Does it have a definite volume or no definite volume? What is the particle speed like? Are they fast? Are they slow? Are they medium? What is the particle energy like? Is it high energy, low energy, or medium energy? What is the particle movement like? Is it vibrational? Is it semi-free? Is it completely free? Those are the kind of things you need to use. You need to tell me two of those about a solid, a liquid, or a gas, whichever it is talking about. Again, it doesn't need to be a complete sentence. You can put no definite shape, but a definite volume. That's all you need to do for those. The multiple choice, obviously, choose the correct answer. If you get to a question you are unsure of and you need help, raise your hand and I will come over and I will assist you. All right? So please, go to work on the quiz, ladies and gentlemen. When everybody is finished, then we will look at what we've got going in our EISN at that point. So go ahead and get to work, ladies and gentlemen. And again, if you have any questions, please let me know. You're going to have to sit there because we don't have the space for you to sit somewhere else. All right, hang on a second here. All right, let me do this, ladies and gentlemen. Take a couple minutes, look over your stuff. I'm going to remove this and I'm going to put a new one back out there for you so that hopefully I can solve this problem right here, right now, once and for all. So give me just a couple of minutes, ladies and gentlemen, and I will get this done for you. Please give me just a couple minutes. Good morning. You can sit wherever you like. We have to double up now because we're taking the quiz right away. So, so you can sit by whomever you'd like. We just tried to spread out as much as we could.
Are you taking a quiz?
I'm trying to. I have to re-put it back out there because I still can't get it to open up for you. So hang on. Give me just a minute here.
There's the back out of the back.
Sure, hurry up. Leave me your phone. Go ahead. All right, please make sure you refresh everything. And I believe it is posted now, and I believe you should be able to get at it. If you cannot, please let me know again, and I will try again. Now we got it. Not bad. Third time is a charm, ladies and gentlemen. Again, you can use your periodic tables, ladies and gentlemen. That is absolutely fine. If you have questions, call me over. I will be happy to answer them for you. Yeah. Bring your phone up. Thank you, sir.
if there are any in the back.
Yeah, also.
You guys are gonna have to start charging your computers at some time. This is first hour of the day.
All right, ladies and gentlemen, everybody is done. So if you would take and open your computers and go to slide number 25, please. Okay, that is where we're at today. I will get your grades put into the grade book by the end of the day today for you so you can see how you did. And I will take care of that. Now, we have been looking at these things, but we haven't officially defined them. We took it and looked at the boiling point and the melting point of a substance. We learned how things can be very different in their boiling points and their melting point and how that determines what state of matter they are. We took a look at the density of 3 different liquids. We found the density of water, of glycerin, and alcohol. These things are properties, ladies and gentlemen, and there can be 2 kinds of properties. There can be physical properties and there can be chemical properties. So this is a short video trying to explain the difference between the 2 for you before we get into it, ladies and gentlemen. So here we go. Okay. Now, here's the big thing, ladies and gentlemen. Some of these things we're not going to talk about. Some of these things we're not going to learn about. But freezing point we already did. If you freeze something, does it change what it is made of? No. Then therefore that is a physical property. A physical property is a property that when it changes, it doesn't change what is actually there. It is water whether it is in the liquid state or whether it is in the solid state. So freezing point would be a physical change. What about if something is combustible? What about if it can burn? Does that mean the substance is going to change and become something different, or is it going to stay the same if it burns? Then that is a chemical property. If it is a property that describes how matter is going to change and become something different, that is a chemical property. So if something is water reactive, anytime you hear reactive, anytime you hear something that is describing a reactivity, that is a chemical property. Viscous, how thick something is, does that depend or does that change depending on, how do I want to rephrase that? Is that determined by how the substance changes, or does that substance just stay the same even though it's a thicker liquid? So in other words, honey is thick. Okay? Does that property describe how the matter is changing or just how the matter is? How it is. Therefore, that is physical. If something is toxic, chemical or physical property? Chemical, because it's how it can hurt you or harm you, right? Condensation point, chemical or physical property? Physical, because again, when water condenses, it goes from being a gas to a liquid. That is not changing the matter that is there. What type of matter that is there? We will not worry about this one, pyrophoric, even though it is a chemical, because we will never discuss that. But we will discuss something being corrosive. If something is corrosive, is that a chemical or a physical property? Because corrosive means it's going to eat away at something. It's going to cause that to change. Okay? That's a chemical property. And then melting point? That is a physical property. Very good. Physical property. So he's going to go through these real quick. Okay? All right. We will cut that off here, ladies and gentlemen. So what we just did is went through the different properties of something, ladies and gentlemen. Let's get to the next slide. So if you had to define it, ladies and gentlemen, I'll fill all this in, ladies and gentlemen. I'll give you a couple of minutes to fill out this slide, and then we will talk about it. So go ahead and fill out any parts of this slide. I think the top few boxes are filled, but I think you have to fill out the bottom few. So go ahead and do that right away, please. All right. So again, the biggest difference, we're talking properties here. A physical property can be observed without changing the substance. By changing the substance, I mean changing what it is made of. If you change that pipe from a solid to a liquid, it's still made out of iron. That is not going to change. If you melt an ice cube, it is still water. That did not change. Okay? If you dissolve salt into water, it is still salt and it is still water. You have not changed them into something new. However, excuse me, Mr. Brand? Yes. Sure, we'll do. Okay, bye. All right. So if it is chemical, the property says this is describing how that matter is going to change and become something new. Dynamite will explode. Gasoline will burn. Paper will burn. Acids will corrode your skin. That means they will eat away at them. They will burn them. Those are all chemical changes because you are creating something new when this change happens. Okay? So some examples. We looked at density, boiling and freezing points. We measured mass. We measured volume. These are all things that can be observed without changing the substance. They are all therefore physical properties. When you talk about something, can it rust? Can it tarnish? Is it corrosive? Is it toxic? Food, will it rot? All of those are chemical properties because they're describing how that substance will change into something new. So the similarities both describe what can or will happen under certain conditions. That's what a property is. A property says this is what is going to happen. Okay? Both can be looked up or researched. If you want to find out if something will react with oxygen, there are ways that you can look it up. If you want to find out if something will react with this other chemical, there are ways that you can look that up. If you want to find out what temperature water will boil at, you can look it up. Okay? The difference is chemical properties do not depend on how much sample is present. In other words, a little bit of iron will rust, a bridge made of iron will rust. It doesn't matter how much size there is there. Okay? Some physical properties do depend on how much sample is there. Mass, for example, depends on how much water you have in the container. Volume, for example, depends on how much water you have in the container or how big a chunk of something you have. Physical properties are how matter looks. Chemical properties are how matter changes. That is the simplest way to describe their difference. Questions? Anyone need more time with this slide? Okay, get done, please. Tomorrow, you are going to look at properties of things. Matter of fact, you are going to determine what is in 4 containers based on the properties of the substance that is inside. So that we are going to do tomorrow in the lab. Good. Can you put away your phone, please? Thank you. All right. So next we're going to talk a little bit about changes. Changes are different. A property is a prediction. A property is something that can happen. A change is an action. Changes are things that are actually going on. Chemical and physical changes here. Whether it is a change or a property, a physical change is something that doesn't create something new. Now, one thing I want to point out, they talked about how you can undo a lot of physical changes. You are not going to put this back together, okay? You are not going to uncut wood. You are not going to uncrumble these cookies. But the point is that when you did these things, you did them and you didn't change what was actually there. That's still the same glass or plate or whatever you broke. The same way with cutting wood. Now, you can't put it back together, okay? So, while it is possible that you can undo some of these, for example, here, where evaporation goes up into the air and then condensation brings it back down to the earth as liquid water, though some of those can be undone, just so you know. That's, all right. All right. We'll finish this tomorrow, ladies and gentlemen, and we will talk a little bit more about these. Have a great day. I will get your quizzes posted by the end of the day today for you. Thank you.